Now we are entering in part 2 that deals with troubleshooting. So first of all, we will see HCU event all OK graph. So this is the HCU event all OK graph, means there is no alarm, it is manual dump, engine was running smoothly without any problem. Here I am going to explain individual graphs in detail. So first one is FIBA set point. So beneath this green line there is a red line which is FIBA set point. FIBA feedback channel 30. This green line is FIBA feedback channel 30. As we know that FIBA set point is superimposed by channel 30. Next one is FIBA controller channel 70. So this blue line is FIBA controller channel 70. You can see this channel 70 line is limited to below 3000. Next one is plunger position channel 31. So this one is channel 31. It is very smooth and you can make out there is no any problem. Next one is exhaust valve position channel number 34. This one pink line is channel number 34. Next one is tacho angle cylinder 1. This yellow line which is not visible properly is representing tacho angle 1. Now these two, FIBA set point and channel number 30, are only above 0 point, this is 0 point, when the fuel injection is done. Rest of the time its always remains below this 0 point. Next point is that this channel 70 line, this blue line, should not be so longer in any direction. That means neither in upward direction nor in downward direction. If it is getting longer, that means main spool channel number 30 is not responding properly, means it is getting stuck somewhere because of friction or because of the some foreign particle or due to the contamination of hydraulic oil. Now moving next, we will see thumb rule. Always use first principle to locate the exact problem. The meaning of first principle is that channel 30, channel 31 is dependent upon the channel 70 and channel 70 is dependent upon the FIBA set point and FIBA set point is dependent on the softwares. So if something goes wrong over here, we will check also that this one or this one is okay or not. If this one is not okay, then obviously this one will also not okay. So that is called the first principle. So we will go a step by a step behind and we will try to find the exact location of the fault. In the similar fashion, tacho angle is dependent upon the tacho amplifier A and B. This tacho amplifier A and B signal is dependent upon the tacho encoder A and B, and this tacho encoder A and B is dependent upon the shaft and alignment. If something goes wrong with the tacho angle reading, then obviously we will follow this sequence in order to find the exact location of the fault. The channel 70 is called control signal, and when it becomes large, then always doubt on FIBA is sluggish, some foreign particle has entrapped between spool and housing. Second, hydraulic oil is contaminated. Third, channel 30 feedback inductive sensor is faulty, and noise issue. When the control signal becomes small, then always doubt on channel 30 feedback inductive sensor is faulty, noise issue. Whole MPC or any particular channel may malfunction. That's I have already several times repeated that not only the whole MPC but particular channel also malfunctions, like channel 70, channel 34, channel 31, etc. If disturbance is in all graph, then doubt on MPC, replace and see. If disturbance is only in one graph, then that particular channel wiring sensor might be defective. Channel 30, 31, 34, 70 must follow and proportional to FIBA set point in particular manner. Now we are going here to see various examples one by one, and in each example we will see various graphs which has some problem and we will try to identify the solution of that problem. So here in this first example you can see that this channel number 30 is not following this FIBA set point. It is going at very large scale. That means there is something wrong with the channel number 30. After that, channel number 70 has stopped responding and hence FIBA has gone in the fail-safe position. This is called fail-safe position, as I have already discussed before. So we will check only FIBA LP channel number 30. This line, that means exhaust valve is open and main FIBA spool is gone down. This position is called the FIBA fail-safe position. Once again reminding you, this spool comes down and hence this pressure port goes to the exhaust valve actuator, hence this exhaust valve opens and this spool closes positively the pressure port going to the fuel oil booster unit. That's cause positively stoppage of the fuel injection. This position is called the FIBA fail-safe position. That means this spool comes down. So this spool, this channel number 30 green line has gone to the minimum position. Example number 2. The alarm is showing burst and preparation synchronization missed. This alarm is new alarm. Don't know much about this one, but we can see here this marker line. Before this marker line something has happened, that's why this alarm has appeared. Can you see this tacho angle graph? This graph is wrong. This graph must be like this one, as I have already discussed before. So when this gone wrong, that's why this alarm appeared. So first of all, what we'll do, we'll check the tacho system. Now example number 3. Here you can see that this channel number 30 is not following FIBA set point and this channel number 70 is trying to adjust this channel number 30 so that it can follow the FIBA set point, but in spite of that it is not responding and as of sudden it start jumping to this very high level and therefore this channel 70 came into action to bring the FIBA in fail-safe position. So this one is fail-safe position. So what can we do? This can happen because of the hydraulic pressure drops or maybe some pipeline disconnected or connector removed. This can be one of the problem, not the whole and sole remedy of this type of problem. This one is FIBA's fail-safe position. I have already explained. Now moving to next example, number 4. In this graph you can see the alarm is electrical noise detected. FIBA set point is in zigzag form, but FIBA channel 30 is following exactly the set point. That means there is nothing wrong with the FIBA channel 70 as well as FIBA channel 30. So avoid that FIBA is sticking. That means main spool is not sticking. One thing is clear. Now from the example I am sure that problem is with the noise only, because everything is looking nice. So I will check noise just because of this wiring, channel number 30 sensor, network cable or MPC issue. Here it is written dither function. What is actually this dither function? This dither function is incorporated in the engine control system software. The function of this dither is when the noise is generated. I explained before that this type of spike generates in the signal. So when any noise is generated, then this dither function activates automatically and this dither function minimize this spike of the graph. It's bring down the spike of this graph to its minimum level so that any disastrous effect should not happen. Now going to example number 5. In this graph, the alarm is exhaust valve stroke low. So first of all, we will see this marker line. Before this, something has happened. Okay, so you can see up to here the fuel injection was happening, but from here fuel injection is stopped. Only exhaust valve actuation is still going on, and we can see before marker line that exhaust valve stroke was coming down. That's why engine control system took a precautionary action in order to avoid any sort of detrimental effect to the engine. So where is the problem? You can see this FIBA set point is looking good. FIBA channel 30 is also following the FIBA set point, so there is no problem. That means FIBA channel 70 is also working fine. Okay, next thing we can see that this line which is responsible for the exhaust valve actuation is okay or not. It is okay. Can you see? These all lines are having same length. That means problem is inside the exhaust valve. The exhaust valve is actually sticking, or the inductive sensor channel number 34 is malfunctioning. So that is the solution of this problem. Please note, even though the fuel injection is stopped, the exhaust valve continues to operate if engine crankshaft is rotating. Here the exhaust valve is continue to operate, but fuel injection is stopped over here. So this is the normal phenomenon of the ME engine. So exhaust valve mechanical part or channel number 34 has issue. So I am going to elaborate it little bit. So conclusion is, all graphs are okay except channel 34, no noise issue. Possible faulty item: exhaust valve, inductive sensor, wiring, MPC. Action: do the function test for exhaust valve several times. If okay, then check for wiring. If not okay, then replace inductive sensor channel number 34. Still not okay, then change exhaust valve. And at the end, we can change this MPC as well, because of fault can happen in the channel number 34 of this MPC. Now moving to example number 6. As this graph is manually dumped, that means we can assume that there is no problem with the parameters, engine is running smoothly. So it is manual dump, fuel plunger okay, exhaust valve okay. This exhaust valve is okay, fuel plunger graph also okay. But in this channel number 70 graph, there is some problem. Although alarm is not coming, engine is running, but there is some problem. First problem is that you can see here little bit zigzag line is present throughout the channel number 70. But in FIBA set point and channel 30, this zigzag line is not present. Another point is that here this channel number 70 line is little bit longer. As I explained before, that this line should not be longer in any direction, either in upward or in downward. But here this is large in downward direction. That is the problematic part. So what we will do? We will check Parker valve, wiring and MPC channel number 70. We will not check channel number 30 because channel number 30 is functioning properly without any issue. But this channel number 70 is not behaving properly. Although alarm is not generating, engine is running without any issue, but later on it will create problem. So first of all, we will check this Parker valve, wiring, MPC channel number 70 and the MPC of CCU 5. You can see the same graph in zoom condition. This channel number 70 has this zigzag line, and another thing is that at this point this line is very large. So this is not the good sign. If this much big line of channel 70 appears frequently and engine is running smoothly, then this might be a sign of the worn out FIBA. That means the main spool and its body is worn out, and in that case we need to replace with new one. So this spool or this main body is worn out. In that case, this sort of big line may appear, but it should be frequent. If it is appearing sometimes, then it doesn't mean that FIBA is worn out. There is some other problem. But if it is appearing frequently, it is a sign of that FIBA is worn out. Now next example, example 7. Alarm is illegal LP FIBA position slowdown. So first of all, we will check this marker line. That means before marker line something has happened. So we will check. We can see up to this point channel number 30 was smoothly following FIBA set point, but as of sudden it went to fail-safe position because this exhaust valve is open and FIBA main spool has gone to minimum position, and still engine control system is continue to send the signal to CCU, but CCU is not responding, means CCU has stopped the fuel injection forcefully. When we zoom this graph, we can find that channel number 30 is actually crossing this zero line. That means fuel injection going to take place. So in order to avoid the fuel injection, the FIBA controller channel 70 has moved this spool to fail-safe position. So now we can see that in this graph, this channel number 30 actually just crossing this 0 line, and hence the FIBA controller number 70 forced main FIBA spool valve to bring it to the failsafe position. So you have to see individual graphs very minutely, that how are they behaving. Now you are moving to see example number 8. In this graph we can see alarm exhaust valve close position change. So we'll see marker of line first. So at this position we can see the fuel injection graph is little bit okay up to here, but here this graph is changed. Also we can see here that channel 70 has become very large, and it becomes very large if and only if main spool of the FIBA is not reacting. That means it is getting stuck or something like that. So large control signal tells that FIBA is not reacting. So let's have a look of zoomed part of this graph. Up to here this graph was okay, but here as the channel 30 is not responding, so this FIBA controller 70 went up in order to bring it to the coincide with FIBA set point, but no improvement. So channel 70 is unable to control FIBA. Next example is example 9. In this graph the alarm is exhaust valve stroke low slow down. So this is marker, so we'll go just before this marker, and we can see there is problem here. This FIBA set point is looking good, also tacho angle is good, plunger position showing erratic, exhaust valve position channel number 34 is also showing erratic. Here the important thing to see is this channel number 30 is not following FIBA set point, and in spite of this channel 70 has stopped giving any sort of command, this channel number 30 is jumping up and down. That means something is very wrong here, but what? Electric signal error, channel 30 or channel 70. So we will try to find out the solution. You can see that channel number 70 is not giving any signal, and if it is not giving any signal, this channel 30 should not react, but it is reacting. That means there is some problem with the wiring channel number 70 of the MPC or the Parker valve itself. Now next example number 10. Here alarm is exhaust close position change. Marker line is not given. You can see up to here this channel 30 was perfectly following FIBA set point, but as of sudden it started jumping, and when you can see it is going down, the FIBA controller channel 70 is trying to pull it up so that it can match with this FIBA set point. It's trying hard and hard, but everything gone in vain. Here also the same thing. This channel number 70 is trying hard to bring back this channel number 30 in its correct position, but nothing is working. So one possibility can happen that this error is dependent upon the other alarm and conditions. The controller might be active and try to control the error. This controller channel 70 is trying to control the error, but it is not controlling. So there are few possibilities. First one is channel 30 itself not working, means channel number 30 sensor is giving erratic signal. Second is MPC channel number 70 is not working properly. Third one is Parker valve is defective. So these three possibilities can happen by seeing this graph. Next example. This is a manual damp. That means there is no alarm, engine is running smoothly. Here this is the enlarged view, and it is written that these spikes are noise from a loose connection which makes noise in the signal when vibrating. So this is just for your reference, that if you find this sort of a spike, then it can be possible just because of wire looseness. So from troubleshooting guide, typical example of noise due to loose connection or defective cable. Next example. This graph is taken from the MEB engine and alarm is MEB piston feedback failure. This graph is also for your reference. This graph is of MEB piston. This graph should be like this one, but it is behaving like this way. That means it is getting stuck somewhere. So this is from troubleshooting guide. piston difficult moving, partially stuck in bottom. Next example, this is manual dump, so no alarm, everything is looking fine. This is also a graph of MEP piston. You can see how this smooth graph is, but in earlier graph it was very erratic. The problem was in the MEP piston, it was sluggish. In this graph it is smooth. Everything look like good in this graph. Only the thing is, here MEP piston activates, but in the next cycle it is not activating. Here in the next cycle also not activating. Here also not activating, but here again activating. Question is, why this is happening? Is this normal or abnormal? Since this is manual dump, alarm has not appeared, that means we can say this is normal, and this happens when the load in the MEB engine fluctuates just around to the 55% of load. So sometimes MEB piston get activates and sometimes not. So this is actually a normal graph. This is not a problematic graph. So looks like normal timing unit problem at deactivation, but occurs at high load and sounded bad. This is zoom of the previous graph. Here you can see this FIBA set point is being followed perfectly by this channel number 30. No MEP piston activation over here, but here FIBA set point is something different and also being followed perfectly by the channel number 30, but here MEP piston get activated. So there is nothing wrong with this graph. Only the thing is, the main engine load is hovering just above and below this 55% of load, and this graph is considered to be normal. Moving next, example number 14. Alarm is illegal LFI FIBA position slowdown. So we'll see marker line. Okay, here. So we'll go just before. Too much problem. Except this FIBA set point and tacho angle, all graphs are having problem. You can see channel number 70 is also zigzag line, channel number 30 also zigzag line, this plunger position 31 also zigzag, and exhaust valve position also zigzag. By observing this graph, one thing we can deduce that since this channel 70 is zigzag, so other channels number 30, 31, 34s are erratic. This may be one of the case, but see here this channel number 70 is in a straight line, but in spite of that channel number 30 is jumping. Also it has moved up, forcing this booster unit plunger to push upward, which is evident from this channel number 31 graph. But wait, there is something more about this channel number 70 graph. Let me first tell you that what is the meaning of this straight line of the channel 70. The meaning of this straight line of channel 70 is that channel 70 is not giving any sort of output to the Parker valve, but in spite of that the control signal comes to the Parker valve, and this graph might be the result of that one. So never ever think that if this graph appears, that means no current is coming to this Parker valve. It can happen that current is coming to the Parker valve, but engine control system is not sensing the current. So what can be the possibilities? Can MPC failure? Or is the channel 70 wiring or Parker valve issue? Yes, the MPC can also failure, and channel 70 Parker valve or wiring can also has problem. So we'll check all these things. Now our next example is example number 15. Alarm is FIBA feedback signal failure slowdown. You can see exhaust valve is open and closing gradually. Here this channel 30 is at this minimum level, that means FIBA is in fail-safe position. Okay, so first of all we'll see marker line. Up to here everything was okay, but as of sudden here something went wrong, and this FIBA control signal channel number 70 is little bit bigger. That means it is trying hard to align this channel number 30 with this FIBA set point, but it is jumping right away up to here, and this large scale is the countermeasure to bring this spool back into this fail-safe position. One more thing we can notice over here, that you can find there is a zigzag line present in this channel 30 graph. Also at the same point zigzag line is present in the channel 70 graph. So this zigzag line in the channel 30 graph is the after effect of channel 70. So what could be the possibilities? Channel 70 of the MPC is defective. Channel 30, this feedback sensor itself has some issue, or wiring has some issue, because this zigzag line is present in the channel 70 as well as in channel 30. So we will check wiring of this both channel and also channel number 70 of the MPC and channel number 30 feedback sensor. Now next example is example number 16. Alarm is illegal LP FIBA position slowdown. This graph is also same. FIBA is in fail-safe position. Now this is the marker line. So we just go before this marker line and we can see this is something unusual graph, because this part is showing that exhaust valve is open and this part is showing that exhaust valve is closed. But the channel number 34 is sensing that exhaust valve is closed and it is moving up, which is not possible logically. So there must be something wrong with channel number 34. And at the same point the problem is with channel number 30 and channel number 70. So we'll zoom this graph for better understanding. So here I have zoomed. You can see at 3 point this channel number 34 is giving erratic signal, which is not physically possible. Also channel number 30 is generating the signal wrong at the same point, while channel number 70 is looking almost okay. So these two graph is erratic at the same point. It can possible only if wiring has some problem, or MPC channel number 30 and channel number 34 is defective, or the MPC is defective. So summarizing, fault seen on 3 signals at once: exhaust valve position here, fuel plunger position actually is not shown here, and FIBA feedback, this channel number 30, almost same value. Common electrical fault on MPC affecting on analog inputs, that means wiring or MPC itself is faulty. So replace the MPC and fault can be removed. Now I am going to discuss about the peculiar behavior of channel 30 and channel 70. Sometimes it happens that channel 30 is behaving wrong and then channel 70 tries to correct it, and sometimes it happens that channel 70 itself is wrong, and as a result of this channel 30 behaves erratic. So question is, how will you come to know which channel is faulty and what to do in order to eradicate the issue? Let's see in the next example. So example number 17. Here you can see that this channel number 34 and channel number 31 graph is absolutely okay, no problem. Also this is a manual dump, that means there is no alarm, engine is running smoothly without any problem. But problem is there in this channel number 70 graph and channel number 30 graph. So in order to get a clear picture, we'll zoom it. So we have zoomed it. This is channel number 70 graph. It is going up, so channel number 30 is also going up. This channel number 70 is going down, then this is going down. It is going up, so it is going up. It is going down, so it is going down. So you can see that this channel number 30 is exactly following the channel number 70, and since this command is in erratic way, this channel number 30 graph is also in erratic way. That means here problem is with the channel number 70, not with the channel number 30. Channel number 30 graph is just an after effect of channel number 70. Means channel number 70 has issue or MPC is kaput. So by this way you can make out that which channel you need to focus on. Now I am winding up this chapter here only. Thank you for watching this video. Bye bye. Take care. Have a nice day.